Welcome to this explainer. You know that mild annoyance when a robotic vacuum just repeatedly bumps into your ankles? Well, today we are going to decode a high-stakes world where robots can do a whole lot more damage than a bruised shin. We're looking at exactly what it takes to lock down the automated systems and physical machines that increasingly share our spaces. Picture this for a second. You're in a hospital, relying on a state-of-the-art surgical robot for a highly delicate procedure. Now ask yourself, what happens if a hacker suddenly takes the wheel of that robot? It's a terrifying thought, right? For decades, robots were mostly confined to safety cages on factory assembly lines. But today, they're moving out onto our streets, into our warehouses, and literally into our operating rooms. And as they do, they introduce severe physical risks if those machines ever get compromised. We aren't just talking about a stolen password anymore. We are talking about multi-ton machines or precision medical instruments going rogue. So here is our roadmap for today. We'll start with when robots become targets, define exactly what robot pen testing is, and explore how hackers actually exploit these machines. Then we'll walk through a 7-step security process and finish up with how we secure our automated future. All right, let's jump right into Section 1, when robots become targets. We're looking at what's known as the physical blast radius. Think about traditional IT security for a minute. It's almost entirely focused on protecting data. If a bank gets hacked, numbers in a database change, or customer records get leaked. Which is terrible, obviously, but it's digital. Robot security completely shifts those stakes. An unsecured robot creates a physical blast radius. The vulnerability moves from the digital realm right into the kinetic, physical world. If someone hacks a delivery drone or an industrial robotic arm, the immediate consequence isn't just data loss. It is the potential for actual human injury or massive physical destruction. Which brings us to Section 2. What is robot pen testing? Defending the hardware-software frontier. So, robot penetration testing is a highly specialized offensive security assessment. Basically, think of it as ethical hackers who are specifically trained to audit machines. But they aren't just looking at standard web applications like your email or bank login. They are targeting unique robotic architecture. They're looking at the robot operating system, or ROS, which acts as the machine's brain, as well as the physical hardware interfaces. They also audit the invisible communication signals, things like Wi-Fi, Bluetooth, and low-power Zigbee protocols that connect a robot to its controller. They test the control logic to ensure absolutely no one can override the robot's intended mission. Let's move to Section 3, how hackers exploit robots. This is where we go from theoretical weakness to very real risk. Now, the attack vectors here are honestly incredibly varied. Hackers might exploit insecure control protocols. For example, many robots use something called MQTT. It's a lightweight messaging protocol that is often just left unencrypted. That's essentially leaving the front door wide open, allowing attackers to sit on the network, sniff out commands, or just inject their own. They can also exploit exposed debug ports. These are hardware ports that are sometimes accidentally left active after production, which grants direct memory access. A malicious hijacking can give an attacker full control of movement. Or, they might just break in to steal proprietary algorithms or tap into sensitive camera feeds, leading to massive IP and data theft. But perhaps the most terrifying exploit is something called sensor spoofing. By feeding fake data to a robot's LiDAR or camera systems, a hacker can entirely trick a robot's navigation system. They can literally make a robot see a clear path when there is a solid concrete wall, or worse, a person directly in front of it. It is a wildly vivid example of how manipulating digital inputs can completely blind a physical machine, resulting in catastrophic safety failures. So how do we stop this? That brings us to Section 4, the 7-step security process. We are hacking robots to save them. Because we are dealing with heavy, moving physical machines, the very first step absolutely has to be safety-first scoping. Professionals define strict operational boundaries to ensure their testing never causes physical damage. They usually prefer to test in highly controlled lab environments. Step 2 is a physical hardware inspection, literally getting hands-on and checking the body of the robot for those exposed ports we talked about earlier. Step 3 is firmware analysis, where the team reverse engineers the robot's software to hunt down outdated code or hidden backdoors. And Step 4 is network and RF testing, analyzing the complex wireless handshakes bouncing between the robot, its base station, and the cloud. And this is where the testing really escalates. Once all those passive checks are done, they move to Step 5, simulation exploitation. Here, they actively attempt to inject malicious commands just to see how the robot reacts. Step 6 is absolutely critical: the HRI, or Human-Robot Interaction Audit. This specifically tests whether the robot's emergency stops and safety kill switches can be disabled remotely by an attacker. Finally, Step 7 is remediation and hardening, where the organization gets a detailed report outlining exactly how to patch up the hardware and software vulnerabilities that were discovered.
Let's zoom out a bit for our final segment, Section 5, Securing Our Automated Future, and look at protection across different industries.
According to the source material, security firms like Cyber Ambassador map their protective services across several key categories of robots. You got industrial robots, securing the massive high-precision arms that build our cars, so production isn't sabotaged. Then there are autonomous mobile robots, or AMRs, navigating those massive warehouses to deliver our packages. We also see medical robotics, where hardening surgical and diagnostic systems is absolutely paramount for patient safety. And finally, drones and UAVs, which require intense security around their flight controllers and long-range telemetry links. Now, across all these very different industries, the core benefits of this specialized testing remain exactly the same. First and foremost, it ensures human safety by preventing rogue scenarios where safety protocols are bypassed. Second, it guarantees operational continuity by guarding against hijacked fleets and massive downtime. Third, it helps businesses meet emerging and very stringent international standards like IEC 62443 for industrial security and ISO 13482. And lastly, it protects intellectual property, keeping competitors from dumping a company's firmware and stealing their hard-earned secret sauce. The crucial takeaway here is summarized perfectly by this quote from Cyber Ambassador. We don't just look for bugs in the code, we look for threats to your physical operations. True robotic security requires an incredibly unique blend of elite hacker skills and deep mechanical understanding. You can't just know how a cloud server works. You have to know how a hydraulic arm or a LiDAR sensor works too. It is the only way to ensure that our increasing reliance on automation remains synonymous with trust. Which leaves us with this final thought. We are entering an era where automated machines are going to be moving through our grocery stores, flying over our neighborhoods, and operating in our hospitals. The convenience and efficiency they promise are incredible. But as they increasingly share our physical world, can we really afford to leave their blast radius unsecured? Robot penetration testing isn't just an IT upgrade. It's a fundamental requirement for a safe future. Thanks for joining me on this explainer, and I hope this gives you a completely new perspective on the invisible digital battles keeping our physical world safe.